back to section 3.1 and do a quick review of functions. So it starts on page 114 if you want to go back and look in the book and get a thorough review. This is going to be a pretty quick review. So functions have properties associated with them called their domain and range. And how I think of it is if you were going to look at one of these graphs in a viewing window on a graphing calculator, say, the domain says how wide does that viewing window need to be to see the entire graph. And the range says how tall does that window need to be in order to see the entire graph. So more formally, the domain is all of the allowed values of x, and the range is all the attainable values of y. It's all the values of y that you can get to using that function. So a function has to have one and only one range value for each value in the domain. That's really the main requirement for being a function. There are a lot of ways of expressing a function: a map, a graph, a table, an equation, or a verbal description. And each of these has its merits, and so that's why there are so many different ones. And there's a way to use each different way of showing a function to decide whether what you're looking at is indeed a function. So let's focus on maps first to absorb the concept, and then we'll look at graphs so that we have a visual representation. So first I want to look at a map, which is a price function. Potentially what we're trying to figure out is something a function? So this is prices on items at a store. Imagine a local convenience store. And suppose coffee is 79 cents, hot dogs are 99 cents, sodas are 89 cents, and chips don't have a price. Well, in order for this map to be a function, every item needs to have a price, and every item has to have only one price. So this map fails the first test, and every item doesn't have a price. So this is not a function. Okay, so let's draw another one. Suppose coffee goes to 69 cents and 79 cents. Hot dogs and sodas go to 89 and chips go to 99. Well, the hot dog and the soda being the same price is fine. The clerk will know how much to ring up for each item. But the fact that coffee goes to two prices, completely confusing. So one item has two prices, so not a function. Okay, but it's perfectly okay for coffee and hot dog to both cost the same, and soda to have a price, and chips to have a price. This is a function because every item has a price and every item has only one price. So if you see this on the map, this is a problem, but this on the map is not a problem. Okay, so the second way is with a graph. That's the easiest because if you can see the graph, we have something called the vertical line test, and we just look and say, if you run vertical lines across this function, do you ever hit it more than once? And this first one is the graph of a function because you never hit it twice. Even at x is 2, the colored dot at the top says the point 24 is on the graph, but this open circle says the point 21 is not on the graph, so we're good. Every x value that's represented on this function has one and only one y value. Whereas this function pretty much fails the vertical line test almost everywhere. So this is not the graph of a function. Okay, so do you see the connection between those two ideas? Because they're saying the same thing. Every item has to have a price, and each item has to have one and only one price. So when you're talking about the graphs, you're saying each x value has to have one and only one y value. So in our class, we're going to focus on three functions mostly: revenue, cost, and profit. So please get in the habit of using capital R, capital C, and capital P, because lowercase r gets used for something else, lowercase c gets used for something else, and lowercase p gets used for something else. Generally, the domain is going to be any real number, but usually positive, especially if we're talking about producing manufacturing items like washing machines. You only can have positive values. But the range can be positive or negative because it's possible to have negative profit, to be losing money. So the only time we have to be careful about domain is if there's a square root or a denominator, or both. So for the square root, we know we don't want to take the square root of negative numbers. So we want to make sure x minus 3 is positive. Well, this is the math sentence that says, make sure x minus 3 is positive, and it's okay for it to be 0. So then you solve this little inequality and say, in order for this square root to be defined, x has to be greater than or equal to 3. So this is the domain. X value can be 3 or bigger, but it can't be smaller, or this whole thing's not going to work. Okay, so inside a square root, that's one issue you just need to be mindful of. And then the other one is denominator. So it's important that we don't divide by 0. So x plus 3 should never be 0. So x can't be negative 3, and that's the domain of this g function. X can't be negative 3, or that would cause trying to divide by 0. Okay, and then I just want to refresh your memory on this function notation, where if I have f with a number in parentheses, it means everywhere you see that number, replace x with that number. So f of 4 would say put a 4 everywhere you see an x, and you'll have the square root of 3 over 15. Okay, and then it's important to keep the numbers in parentheses. For example, if we're looking at b and we want to know what is f of negative 3, well then we kind of have a problem here, right? We're trying to take the square root of negative 4, so we say this is undefined. There is no point on the graph of this function for x is negative 3. It does not exist there, so it's undefined is the proper term. Okay, and then let's look at this other function and just do one of those and say, well, here f of negative 3 is the square root of the opposite of negative 3. So then we're fine because we have the opposite of negative 3. So that's going to be the square root of 3 plus 2 over negative 2. Well, that's going to be the square root of 3 minus 1. Okay, so you have some homework problems to practice on those, and I want you to practice using the notation. Make sure you're writing this f of negative 3 part and then saying what it is. Okay, then another thing I want to refresh your memory about is when I want to evaluate a function at something that's not a number, I can evaluate it for any algebraic expression. And it says wherever you see x, replace it with what is inside the parentheses. So I would have the square root of 4 minus the m plus 3. So really you can think of this function as instructions. It says do 4 minus whatever's in the parentheses and then do the square root of that. Well, you should simplify this because this is 4 minus m minus 3 in a square root. So 1 minus m. And that's your result. So a function can be evaluated for any quantity that's inside the parentheses. And we're going to do quite a bit of that. So hopefully it will just all start coming back to you of how that works. So here I want you to find f of x plus 3 when this is the recipe for f of x. So some people find it helpful to do a technique like this where they say, let me put empty parentheses everywhere I see an x. And then I'll put the x plus 3 filled in to each set of empty parentheses. And for some people that's a helpful tool. Not required. Okay, so then we recall that x plus 3 quantity squared means x plus 3 times x plus 3. Then I have minus 2x minus 6 as I distribute. So then I'll have x squared plus 6x plus 9 minus 2x minus 6. So I'm going to collect my like terms. I don't have any other x squareds, but I have 6x minus 2x, so that's going to be plus 4x. And then 9 minus 6, so that's going to be 3. So when I evaluate this given function for x plus 3, I get x squared plus 4x plus 3. Okay, so again, I'm going to pause so the movie doesn't get too long, and then we'll come back and we'll do properties of limits to start looking at finding limits of a formula.